this block, the rectangular, and this would be 4/7 of XU, this parabolic portion. So आपका, now if you want to actually calculate the overall C, what would be the overall C, the compression forces? That would be compression forces C1 and C2. So it would be C1 plus C2. Now, if I want to calculate C1 first, that's for the rectangular section. What is the stress in the rectangular block? It's again 0.447 FCK. The maximum one is 0.447 FCK. ये आपका stress है, this in this rectangular block. Then into B is your width of this rectangular block, but it's acting only now not over XU, it's acting only over 3/7 of XU. तो एक तो ये आपका C1 आ गया, this is your C1 plus now your C2 is acting in this parabolic portion. So what is the maximum? In a parabola, you have 2/3 of this base into altitude. So now here this is 0.447. It will be 2/3 of what is your stress? It is again 0.447 FCK into this B again, and then not 3/7, this is 4/7, 4/7 of XU. So this is, it should be here, this 2/3 should be here multiplied into this, but it makes no difference. You multiply it inside or outside. So this is your C2, the compression stresses in this parabola. So total C, I have already calculated this. It comes out to be 0.0362 FCK into B into XU. After multiplying this all and adding them both together, that's what we get, 0.362 FCK into B into XU. And we already have T is equal to 0.87 Fy into AST. We already have this. So because in the balance section, C is equal to T, so actual value of, once you have C is equal to T, would now be if you have XU by D to be calculated, would now be 0.87 Fy AST by 0.362 FCKB into D. This is FCK into B into D, 0.362 FCK into B into D. So this is the value of XU by D, which you get in reality, and that is mentioned in the IS code. Let me show you that. So you go to IS 456 page, this is Annexure G, page number 96. There you will find this. XU by D is 0.87, FYAST by 0.36, it's 0.362 exact, FCK into BD. So this is your XU by D that you are also then getting in the IS code. The earlier one where this was coming to be 0.447 FCKBD, not 0.362, that was on the assumption that the section is rectangular, and that's also used in the working stress method to get a balanced section design. So, but you have to use the exact one, and this is in the limit state method, you will be getting this 0.362 in place of 0.447 FCK. So once you have done this, now what we actually need to do, we need to determine the moments. So what are our moments for this section now? We now know that this beam section has got a C value, we know 0.362 FCK into B into XU. We know its T value, which will be in opposite direction, T, which will be 0.87 Fy into AST. We know these two values. Any one of you who knows what is the moment equal to? You must have studied in physics for a section. What is moment equal to? Force into what?
Perpendicular distance.
Yes, a lever arm or a perpendicular distance. So both of these are forces. C is a compressive force and T is a tensile forces. Both are acting. They are not acting in different directions here. I'm just designating them as acting here and there. It's not acting in different direction. You have load coming like this onto the section. So this is coming in compression and this portion is getting into tension in this plane. ये ऐसे जो मेरा स्क्रीन है कंप्यूटर का उसके बिल्कुल अपोजिट परपेंडिकुलर ये खींच रहा है ऐसे. Not in these directions. It's just to show it's actually outside the paper से बाहर ऐसे खींच रहा है. ये यहाँ पर it would be इसको मैं अगर कहूँ तो ये बाहर की ओर खींच रहा है और that's compressing in this plane along screen के बिल्कुल अंदर ऐसे compress हो रहा है. That's what I actually mean here. So moment is the force. Compressive force ऊपर है and tensile forces are here. The moment would be the lever arm between the compression and the tension forces. So if you already had that stress diagram, if that was like this, remember this is a stress diagram at a section. ये जो black line इधर मोटी वाली है, this is the section. ये इसका वो वाला view ऐसे. That's what this stress diagram is showing. So there is a lever arm Z. Any Z is your lever arm between the two forces. So your moment for this section would be T into Z, or it would be C into Z. If the section is balanced, if T was equal to C, if the section was kept as balanced, then moment would be either T into Z or it would be C into Z. If this is a balanced section design, but if the section is under reinforced design, it would be only T into Z, because that will give you the maximum moment then. In an under reinforced design, that will give you the maximum moment. This maximum moment for under reinforced. और अगर ये over reinforced है, then C will be dictating. In an over reinforced design approach, it will be the C will be dictating. So there the moment will be C into Z. For a balance section, quite easy. T is equal to C, so moment will be T into Z or C into Z. Now what is Z here? This Z value, the lever arm, what is its actual value? We know this is XU, and we know this is D. Now C will be acting at some centroid from here, and that would depend on simply C into centroid would be, it was made up of two components, C1 into what was the center of the rectangular portion above. Where did this go? Yes, here, 3/7. So 3/7 ka 2 half. This would be 3/7 XU. Uska half, क्योंकि you have to take the centroid of each one of these, plus you have C2 into 4/7, which is the rest portion. XU, it's acting as a parabola there, so it would be at 1/3, and then divided. So this will give you the XU centroid in both the cases. So it's the, so overall then X bar that you get here is 0.612 into XU, जहां पर एक्ट कर रहा है. You need not calculate this. I'm just trying to show you. So this is your, in your code IS456. What does it say? If just go to this second clause, if the value of XU by D is less than the limiting value, that means XU by D is less than limiting value is जो हमने last time पढ़ा, XU max. What was XU max? What was XU max? Any one of you? We studied this in the last class. None of you knows what was XU max? XU max we calculated for when it was a balanced section. For an under reinforced section, XU will be less than XU max. I told you this last time. So when XU by D is less than XU max by D, this is what the meaning of this is. Calculate the moment of resistance by the following expression. So this is your moment of resistance of the section. So for an under reinforced section, it will be decided by what? It will be decided by, I told you, T into Z. So T, what is the value of T? M is would be equal to, for under reinforced section would be T is 0.87 Fy into AST into Z. So this would be 0.87 Fy into AST. So the rest portion is Z. This, as per the code, is the value of Z. So what is this? If I open this up, this is D minus D into AST into Fy by BD FCK. And you know this is AST into Fy by BD FCK is this. it would be equal to what? अगर मैं इसको यहाँ पर from the balance design, it would be AST into FY by BD FCK would be 0.36 XU by ये इधर जाएगा and this would go here. Yeah, I just calculated this. D is D minus D into AST FY BD कितना आया? This is coming to be 0.41 into XU by D. So I can say it's D into 1 minus 0.41 into XU by D. This is not 0.41 aa raha hai, not 0.61, it's 0.41. So M you would be getting as 0.87 into Fy into AST, T ka value for under reinforced design into Z ka value, that's D minus 0.41 XU. This is what you are getting. So overall, the expression, you can just use the expression from the code. This value has to be considered as per the code. So you can use this formula from the code to calculate the value of MU for an under reinforced design. For over reinforced design, when the value of XU is equal to the limiting value or greater than that. Now, if it's equal or balanced, you can use C. उसमें तो you can use M is equal to T into Z or C into Z. But here you can use XU for the limiting value. If it's XU is XU max equal to XU max, that's for balance section के लिए जितना बराबर आता है. Then we will be using this expression. कौन सा expression? C into Z. What would be C into Z for over reinforced design? It would be M. What is C? 0.362 FCK into B into XU. तो ये वाला portion cover हो गया. This one.
सर X बार क्या है वहां पे?
कहां पर?
सर पिछली वाली स्लाइड में.
It is this. Yeah. It's the centroid of the compression जहां पर आपका act कर रहा है. C is composed of two, C1 and C2. तो उन दोनों का मिलाकर you will be getting X bar. If you have to calculate X bar, how do you calculate centroid? You calculate it by C2 into यहाँ तक कितना आ रहा है इसका center, इसके center से यहाँ तक, then C1 into this divided by the total forces into center. That's how you calculate it. So both sides of the equation would be calculated as per that. C into the center of this would be equal to C1 into this and C2 into this, right? So
जी.
So what I was telling you now, if you have M, this is 0.41. If you have over reinforced design, C would be 0.362 into FCK into BXU into Z. So Z would be again D minus 0.412 into XU, like that. So, but you can use this expression as per the code which is given, this one. What the code has done, actually it's 0.362 into FCK, वो इधर गया. 0.362 FCK into B इधर है. Then you have XU. code uses XU or XU max here because here XU is already equal to XU max. So code is straight away gone into writing XU max for XU जब balance design है. So again, let me share. This is FCK B into XU. तो ये सारे components आ गए. This was just a minute. So FCK आ गया 0.362 आ गया. XU max in place of XU into B. Now what remains is एक तो ये D and ये D. तो ये cancel out हो रहा है into D square. So none of it actually matters. ये D आ रहा है and this D. So then it's 1 minus 0.42 again into XU, which I was just telling you. There has to be one more D somewhere here. D into D minus dt. So this is the, now if your XU is by D is greater than limiting value, this is for balance section. When you, now for there MU becomes MU limiting. It does not remain as MU. MU limiting means limiting का क्या मतलब है? इससे ज़्यादा नहीं हो सकता, इसकी रेजिस्टेंस सेक्शन की नहीं हो सकती. इसका ये मतलब है कि बैलेंस सेक्शन में सबसे ज़्यादा रेजिस्टेंस, मोमेंट ऑफ रेजिस्टेंस एक सेक्शन की होती है. नाउ आई एक्चुअली वांट यू टू कंसंट्रेट ऑन दिस दैट देयर आर टू थिंग्स हियर. वन इज जो लोड एक्ट कर रहा है, द लोड इज एक्टिंग ऑन द सेक्शन, दैट्स वन थिंग. तो उससे क्या डेवलप हो रहा है? बेंडिंग मोमेंट्स डेवलप हो जाएंगे. लेकिन वो फ्लेक्सुरल लोड्स जो बेंडिंग मोमेंट है वो किसको लेना है? सेक्शन को लेना है. एंड दैट शुड रेजिस्ट. व्हाट आर वी कैलकुलेटिंग? वी आर कैलकुलेटिंग द रेजिस्टेंस ऑफ द सेक्शन. जो हम ये कर रहे हैं, दिस इज डिटर्मिनिंग द रेजिस्टेंस ऑफ दिस सेक्शन. विच सेक्शन? दिस बीम सेक्शन is that should be less than this resistance. तो जो भी आपको मोमेंट जनरेट होगा ड्यू टू लोड, जो ये गुलाम अब्बास अभी कह रहा था, WL square by 8 for simply supported and WL square by 12 for fixed, and similarly you could have other criteria like for cantilever WL by 2. तो वहां से वो आपको मैक्सिमम बेंडिंग मोमेंट जनरेट हो रहा है, फ्लेक्सुरल स्ट्रेसेस डेवलप हो रहे हैं ड्यू टू लोड. और वो किससे कम होना चाहिए? इस वैल्यू से कम होना चाहिए अगर आप डिजाइन अंडर रीइंफोर्स कर रहे हो. अगर आप बैलेंस डिजाइन कर रहे हो तो इससे कम होना चाहिए. और अगर आप डिजाइन ओवर रीइंफोर्स कर रहे हो तो क्या कहता है कोड? इफ XU इज ग्रेटर देन लिमिटिंग वैल्यू द सेक्शन शुड बी रीडिजाइंड. अगर XU इससे ज्यादा चला गया, XU मैक्स से ज्यादा चला गया, तो सेक्शन आपको रीडिजाइन करना है. इसका ये मतलब है कि ये लिमिट है, ये लिमिट, दिस इज लिमिट. लिमिट क्यों है? लिमिट इसलिए है क्योंकि कॉन्क्रीट विल फेल इन अ ब्रिटल मैनर. तो कॉन्क्रीट की रेजिस्टेंस इतनी ही है, दिस मच. उसकी मोमेंट ऑफ रेजिस्टेंस इतनी मैक्सिमम है, फिर उसके बाद वो फेल हो जाएगा. अगर आप उससे ऊपर भी इसको ले रहे हो फिर तो वो फेल हो जाएगा इन ओवर रीइंफोर्स्ड सेक्शन. इन कॉन्क्रीट में ब्रिटल फेलियर होके वो फेल हो जाएगा. सो we have to redesign this. So our design approach in limit state method of design as per IS 456 is balanced design. तो balanced design है ये approach. IS 456 sorry under reinforced approach है.